My name is Golbu Barghouti. Welcome to our healthcare poster showcase for GTC Spring 2023. We hope you all enjoy the following poster selections as part of our healthcare track.
Hello everyone, my name is Dr. مراد بوعاش. Today I'm going to present Demato.AI, which is a tool for skin disease detection using artificial intelligence. This work was made by يهدف, who's the developer or the artificial intelligence engineer or developer on this project, myself, and also Dr. Sursan Shiddadi. This is part of the company or startup in Algeria, which is built actually in the US and in Algeria. The name of the startup is Algeria-AI. It's a startup focused on solving problems, real problems, using artificial intelligence and data science. A lot of fields we're trying to tackle: healthcare, one of the projects or tools, Demato.AI, but we are working on brain, lung disease, and jaundice for babies, environment, agri-tech, and beauty tech. So why Demato.AI? We know that derma disease are a common condition in different varieties and causes. Most of them, they are not dangerous, of course. Sometimes we have them, and that's normal, but some of them, they are very, very dangerous, and it's good to have a tool that can identify, detect, and segment. And this tool, Demato.AI, is actually segmenting or detecting and identifying 3 types of similar-looking skin disease. The goal here is actually understanding the skin condition, and Demato.AI can be used by non-medical individual for diagnosis, but also can be a very good assistant for doctors working on this field and helping them to make it fast by just few clicks. So this tool can be used by doctors in order to confirm the correctness of the diagnosis they have. Of course, we know that they are really busy and they need tools, and of course artificial intelligence is going to be a great decision or great tool here to use to help them make their work perfectly. Our methodology is actually based on having a lot of the data set, and this is what we are trying to focus here. And also we get our artificial intelligence model gets the input image from the user and make some prediction and give at the end some outcomes or outputs that are going to be the final decision that can be helpful with high accuracy. So we made our AI artificial intelligence data set realized with the label with 3 different methods or 3 methodologies. First, we use Keras with a TensorFlow backend. We used the same API to trade the CNN with globe average pooling 2D to be able to use the conventional part of this model, and also mask the RCNN provided by the Dictron2 library realized by Facebook for more accuracy, but unfortunately we have a slow performance. So we're trying to get a compromise between the accuracy and also the speed. The data set is a collection of open source data set, and the verification of this data set is also made by our tool. And then we are carrying out the model with different methods to choose the best way to satisfy this project with a maximum data set or maximum images that we can collect. So the images, they were collected from different websites, and one of them is Kaggle. Everyone knows about Kaggle. And then the annotation, they were created using Label.Me, which is the graphical image annotation. Here we talk about the implementation. As I said at the beginning, we have experimentation of 3 different methods. The first one is semantic segmentation with the UNet. The second one is anomaly detection with the CNN or conventional neural networks, and the last one is object segmentation with a mask RCNN. So talking about semantic, just giving a little bit of overview for the semantic segmentation, is a creation with Keras and TensorFlow, and then we loaded the augmentation of the dataset on our Colab environment, which is a Google Colab, using GPUs for training, and we trained for 30 epochs, which not be too much, I know, but actually we have a good result using this methodology. The result of this methodology, when we talk about accuracy, it's a quick learning. It went to 92 train and 90 in validation and only 30 for epoch. And the IOU, which is the intersection over the union, they represent how much the model will detect from true one. And at the end, we have the loss, which is the first effort at 0.5 to 0.3. And for the anomaly detection, which is the second methodology that we are using, actually this is architecture for the neural network, and it's like normal CNN, but we are taking the output, the less conventional, then we learned from the output for the features, and then we do it as a pipeline, as you can see it on this picture. And then we do transfer learning with the VGG16 and set the last of the conventional layers to be trainable after this. The result, no need for mask here. So this is why we are using this methodology. And we use the ADAM optimizer with the 0.01 learning rate. For the last methodology, which is the object segmentation, we are using different AI tools, using TensorFlow and Keras, Mask RCNN, proposed by the Dectron 2, and the object detection toolkit made by FAIR, which is a Facebook tool coming from the Facebook research lab. And the result also changed the dataset from label me format to Coco. And then we have the Dectron 2 dataset class, augmented the dataset and loaded it. And we have training using the Mask RCNN with a learning rate of 0.002. The best training method at here, and we have in 5,000 step gave 0.98. The performance at the end, which is the big result, we have the three different methods. We have selection of the Dectron 2 model for many reasons, and one of them is of course, we have slow performance because we don't have enough GPUs for training, but more accurate. Of course, here all the GPUs that we are talking about are Nvidia products, available in the professional version of Collab. I'm talking here about V100, H100, and A100 GPUs, but we have access only for one or two maximum because of the load balancing that we have through the GPUs for different other people that are trying to use their GPUs. We can see in this table, we have the accuracy for the semantic segmentation, object segmentation, and anomaly detection. And we can see that the Dectron 2, the model that we used, is one of the best, but we have slow performance, which can be solved by more GPUs. This is going to save us a lot of time when it comes to training. So we created this UI. We have the internet web page or the mobile application. So this is going to make it easier for people to use it. So this actually is available through internet. You can go to the Algeria-AI.com, and then you just click on the project Demato.AI, and then you see this available. We have a lot of features. One of them is disease detection, disease definition, and also awareness. For people who are not from the field, they can understand it very quickly and very easily. For people who are doctor, they are already on the field, it's kind of very helpful for them to save a lot of time. So here, conclusion, it's about the question why we need this segmented disease. It's to help and assist doctors in the future extract additional information from image, like disease area radius in few minutes, a few clicks, as I said, and then we have a lot of additional features that can use by Demato.AI. So just go to the webpage Algeria-AI.com, Demato.AI, and then you can use this tool. Thank you very much. Appreciate your help, and then appreciate the time from Nvidia to give us this opportunity to talk about our project. I would like to thank the developer of this tool, Iyad Meshigig, and Dr. Sawsan Shidadi, and all my team collaborating to make this happen.
That the model has never seen in training. It's uploaded and click on this prediction button.
I'm going to skip the prediction time because it takes a long moment.
Correctly, and we have the class along with how much it is or the prediction accuracy. 76 is amazing. Let's start with other images. For example, this novice image.
Let me skip again the prediction time.
As you can see, we have detected again novice in this image. Let's start with a cat to this image. Enjoy the video. Goodbye.
Hope you enjoyed this presentation. Goodbye.
We hope you enjoyed our healthcare poster showcase. We have much more content for you at GTC Spring 2023. Be sure to visit our session catalog for more offerings.